Hello everyone. Today and in these couple of days I've been working on my game from scratch in C++, and today I want to show you like the new things that I added since the last time. And as always, let's just step through the code to see what happens. We press F11. Now we see like we got the main entry point. What I call this check for memory leaks on exit, which just calls this function crt set debug flag. This function is a Win32 function that is very useful because with it you can track basically memory leaks, and like when your program exits on the Visual Studio output window, which is like this thing right here, which basically gets all the output, your standard out and standard error, but also strings logged with the output debug string. And in this output window, basically it creates your report of all the memory leaks and also from which part of the code the memory was leaked. So this is like a fine addition, I think, because if we are in debug mode we check for memory leaks at the end of the program. Now we step into Fox entry. Fox entry is the entry point of our application. As you can see, I've split all the code into multiple files, just because it's more convenient to do it in this way. Now I create a Fox application, which is the de facto chunk of memory, the biggest chunk of memory, in which all the data is stored, with some exceptions. I create an application, I simply allocate our Fox app, and then I create a runtime, and then I create a GFX. The runtime, you've seen it like you have already seen it the last time. So basically the only addition is that create runtime actually does a memory allocation. This is because I have split since like runtime.h, like this is an opaque struct. I did this because in the runtime the Fox runtime app is actually platform dependent, and right now I'm targeting only Windows, but first and foremost, you never know if we'll target another platform, so it's fine. But more importantly, I don't want to always include Windows, and I don't want my entire code base to depend on Windows.h, because if we were to like port the game, then to another platform, I would have to restructure the whole thing, and secondly, I don't like including things that I don't need, so I like to isolate things in order to make them simpler, basically. So right now we see the allocation. We simply do the allocation. We pass a runtime message buffer, which is basically the message buffer that we use, so there is nothing new here. And yeah, that's everything like last time. Now this is the new module I've been working on, which is basically the graphics module, or you could call it the renderer, but I'll also use it not only to render stuff, but right now it's only a renderer. We pass like the window handle that we get from the runtime. because we need it. Oops. Okay. Now we can create our GFX or graphics, basically struct. As you can see, like this struct is just a wrapper around direct 3D11 comma pointers. My gfx.h is also a opaque struct for the same reason. I don't want my entire code to depend on it. I don't want parts of the code that don't need to know that I'm using direct 3D11 to actually know that we include direct 3D11, and I think this is it makes the code more clear, basically. Now I allocate my the GFX point, my Fox GFX. Now I create a direct 3D11 device. Here I want like really go into the specifics, but basically because like you can find a lot of guides on how to initialize direct 3D, but to give you a very high level view, you just need to create a device using the direct 3D11 create device function. It's very well documented, so you don't really have to dig through a lot of documentation. Now I simply like set some debug settings that could be useful when I'm debugging, aka breaking, like activating, entering in debug mode when there is a error or a like on different severities, basically on severity error and severity corruption. Then I do some cleanup stuff. Then I create a swap chain. The swap chain needs the window handle, that's why we need it. And the swap chain, to create a swap chain is a little bit tricky. The guide I found online actually made these steps, but I've also seen other guides that follow different steps. But for me, I simply got a DXGI device from my direct 3D11 device. Then I got the adapter from our DXGI device. Then I got this is entirely optional, I got a description of this adapter. This is useful because you can see, I'll show you through the debugger. Like in the DXGI adapter desk, you can see the description, which is a string. Now it's not a lot readable, okay, which basically tells you like the name, a descriptive name of the adapter that you are using. In my case, we're using the RTX 360 Ti, which is my GPU on this machine. Now I get the parent from my DXGI adapter, and that is the DXGI factory, and then I fill in a swap chain description. Nothing really important apart from the fact that I'm using RGBA unorm as RGB instead of RGB, standard RGB. Gamma correction, basically RGB with gamma correction. Now I just use the DXGI factory to create the swap chain. I release the things that I don't need, and I return the pointer to my swap chain. Now now Direct 3D is initialized successfully. Now we need another thing in order to render, which is I need to get basically a render target view of our of a buffer that is inside our swap chain, and by default I simply get the buffer at index 0, which is the first buffer. Then I create a render target view from this buffer, and this is necessary because of D3D11 specifics. Now everything is done. I initialize IMGUI because I have added IMGUI into my application, and I'm basically follow all the default initialization of IMGUI. You can find it on the IMGUI in the IMGUI repo. The only thing is that I'm using the docking branch instead of the main branch, but it's basically the same thing. So I'll skip it, and then I simply fill in all the things I need. I fill my FoxGFX application. Now everything is set and done. We can finally run our application, and this is very simple. While our application shouldn't close, we simply update the application. Now the update is made of different steps. The first step is getting all the runtime messages, and this is basically, we have already seen this in the previous video, so I won't really delve into it right now. Then we iterate over the messages. Right now though, I'm iterating over the entire buffer, but I don't actually need to do this. Up runtime messages dot next. Yeah, I could simply iterate over the first X messages, where X is actually the next index basically. In this way I don't iterate always over the entire message buffer, even though I don't have any even though any messages were actually pushed into the buffer. So let's just stop it. Actually, check if it's working. Yeah. Okay, so let's just do this. Perfect. Now there won't be any messages right now. Yes. Now I clear the runtime messages. This is important because on the next frame we want our we want to clear our message buffer, because messages are valid only per frame basically. And that's the same thing. I clear the buffer, and oh, that's a bug. I have just spotted a bug right here, because I am buff next is must be 0. I don't have any other. Yeah. I also need to set the buffer to 0. I spot, like, sometimes I do some stupid errors just because I write a lot of code, and sometimes it just slips. Okay, now I simply mem0 the whole array. Okay, now that's the new part. How did I choose to interact and make my renderer basically? So instead of using a something like a class, okay, where you have like clear. Oh god, that's not a good idea. instead of having a class and or basically a struct here and doing fox gfx clear and passing the gfx, or doing fox gfx render mesh and pass like gfx the mesh, maybe the material and all. Instead of doing these, I choose a more I think interesting approach, because I push, like my application holds a buffer of graphics commands, and I just push push commands on this buffer, and once I've finished pushing these rendering commands into my GFX command buffer, I just submit it to the renderer. So basically just write a command into the buffer, and then I say to my GFX, to my renderer, execute these rendering commands. And here you can see, like, this is all IMGUI stuff, so we'll gloss over it. But then I say output merger set render target, and I set as a render target my swap chain buff 0 render target view that we got earlier. And now I simply iterate over all the commands, and based on the type of the command I do a thing. Right now I don't like. Right now I'm not doing anything because I'm still like working on it, but I would like execute, in this case, my command is a fox gfx command clear, as you can see. So basically F10 here, I would like execute this function exec clear command, and with the exec clear command basically I do all of this. Here, like, just to be clear, I'm not doing it because I was working on integrating IMGUI, but I wanted to also publish this video because it's I wanted to show things as soon as they are working, just not to add a lot of stuff and do a huge video basically. So we got the thing, we are iterating. Okay, this is all IMGUI. This is what we should have done here. I do it here because right now I have only one command, but that's obviously temporary. So I clear the render target view with a given color, which is this color. Right now it's black. And then I do some IMGUI thingies, and then I simply present the swap chain using vsync. If you put 0 here, you don't use vsync. Now, right now, I have pushed my rendering commands, I executed my rendering commands. Right now, this thing, like clearing the command the GFX command buffer, doesn't really matter because I always submit the same buffer, the same command. But in the future, maybe, in the future, we will be submitting different commands, and they may change frame by frame. So, since like our GFX commands are valid only during the lifetime of the current frame, at the end of the frame I just clear. Once I've finished using them, I clear the GFX command buffer. Why am I using commands? I'm using commands just to make the game architecture more modular, where I don't depend. I want to, when possible, I want to pass messages instead of calling functions, because in this way I entirely decouple the caller, which is the app, with the callee, which is the GFX commands. I could always, and a more important thing is that when submitting an entire batch of graphics commands, I could actually optimize how my commands are executed, especially if the order of some commands don't matter. I could partially reorder them and execute them so that, for example, I could batch render one. I could optimize the rendering basically. And in this way, passing messages and submitting like this huge buffer, this batch of commands, instead of executing commands one by one, we could potentially create a thread that executes the when like the graphics commands are submitted. We use a thread. This function could pass the commands to a thread, and then in this thread we could potentially like make our renderer and our main thread, our rendering and our like standard application, we may be able to use it on different threads, which is like a plus. I still don't know how to do it, and I want to implement the renderer first, but the idea at the end is to make it like multi-threaded, and I think that this way of passing a batch of messages of commands is more elegant and easier. Now I simply do the same thing over and over again, so it doesn't really matter here. Now we execute the entire application. You see the IMG UI thing. You can see all like, and here I can change the clear color based on the color I pick. This is nothing like, this is not mine, it's just a library. As you can see, I can move the windows, the windows wherever I want, and these windows have also docking capabilities, which is very nice, in my opinion, at least. Now, yeah. I think it's a good addition, at least. There is like one thing that might look wrong, and is that this is not the IMG UI, the usual dark style of IMG UI, because I'm using sRGB instead of standard RGB, and the colors for this theme I think were made for like standard RGB and not sRGB. And I had this little bug where here I would have these colors, but here I would have, once out of the window, I would have the normal colors. This is because by default in my IMG UI implementation, which is obviously the direct 3D11, the created swap chain uses an RGBA format for the swap chain, but I need an RGBA, I need a sRGB format, so I simply commented out this line and used this other line, and it basically fixed itself, even though the colors are slightly off. So like, whoops, okay, now when we exit, okay, perfect. Now this is set to close because we have like triggered the runtime message quit, and we simply destroy the application. We first destroy our GFX, which is basically finalizing IMGUI, releasing resources, and then freeing memory. Oops. Then I destroy the runtime, and I want to like here is the same thing. I destroy the window, I unregister the window, and then I free the memory. And then I free the Fox app itself, and then I return basically. Now look at what I was telling you earlier about controlling memory leaks, like checking for memory leaks. If I were to comment this line right here, okay, I basically introduced the memory leak in my application. So right now I execute my application, I shut my application down, go on with my life, and I've leaked the memory. Ooh. What? View, obviously Windows, obviously Visual Studio. I did something wrong. Yeah, you can see the output window right now. This output window, in this output window you see like normal block, but it's wrong, detected memory leaks, and it actually gives you the entire path and line, and it straight up jumps. You can click on it and it will jump on it, and you can see that it's telling me, okay, here you have allocated memory but you don't free it. And this works because in my Fox alloc I actually pass a file and a line, which are passed to the Fox alloc row, which basically calls calloc dbg, which passes like the file and the line. Yeah, that's everything to it right now. So if I were to do this and then that, and then like property manager, okay, and then the output, now there are no leaks. So that's all I wanted to show you guys. Stay safe and see you next time.